See, the next one is going to be the basic set of instructions. Instructions. In this particular video, I'm going to demonstrate, or I'm going to give you an idea about the basic instructions that you should know in order to work with the microcontroller 8051. In order to understand the architecture a little more clearly, you need to know some basic instructions. Okay, we know that instruction is nothing but a command given to the microcontroller. Okay, so you can write codes in ASM assembly mode, or else using C language. Okay, so that is depending on the simulator. So like if you are using Keil simulator, Keil simulator, in this simulator, you can write programs in assembly mode as well as in C language, using C language instructions. Okay, and before going to start this discussion, most widely used resistors are accumulator A, B, and R naught, and R1, and R2, R3, R4, and R5, R5, and R6, R7, and R7. So, right. So you can refer to accumulator with its name like A, or else with its address 0E0, 0E0. 0E0 is the address of accumulator. 0F0 is the address of B register. So similarly, so the default, so this R0, R1, R2, R3, R4, R5, R6, R7. So these are register bank registers. That bank may be a bank 0, maybe bank 2, bank 1, or else maybe bank 3. Okay, the default register bank is going to be bank 0. So with an assumption that so R0 to R7, all these are register bank 0 registers. So R0 address is going to be 0, R1 address is going to be 01, and R2 address is going to be 02, and R3 is going to be 03, and R4 is going to be 04, and R5 is going to be 05, R6 is going to be 06. You can refer to, what does this mean? You can refer to R0 with its name like R0, or else with its address 00. 00 is the address of R0. Similarly, accumulator, you can refer to accumulator with its name like A, or 0E0. And one more thing is PSW. PSW means program status word. Program status word. Which is an 8-bit register, Okay, so the least significant bit in this is referred as PSW.0, is referred to as PSW.0. The next bit is PSW.1. So this means PSW.0 means it is a single bit, which is the least significant bit, So similar and so on. PSW.7 means the most significant bit of PSW register. Okay. Similarly, we know P0, we know P1, we know P1, P2, P3, P3. So P0 means port 0, P1 means port 1, P2 is port 2, P3 is port 3. All right. So P0, P0.0, P0.1, P0.1, and P0.2. So P0.0 means the least significant bit. P0.2, P0.3, and P0.4, and P0.5, P0.6, P0.7 or P0.7. So P0.7 is called as the most significant bit. Similarly, P1.0 P1.0 means 4 to 1 least significant bit. P2.1 P2.1 4 to 2 second bit. P3.0 so port 3 least significant bit. So this is how we represent the bits in the respective ports. And C means carry flag. C means carry flag. Okay, PSW is nothing but a flag register. In that, we refer to the carry flag with its name like C. C means carry flag. So B.0 means port B 0th bit. B dot win B dot 1 so means port B sorry B register B register first bit. B dot 4 means B register fifth bit. We refer to that like this. So and DPTR it is a 16-bit register. You can refer to the DPTR directly with its name and DPTR is a combination of two registers. One is DPH. Okay, DPH means data pointer higher and DPL data pointer lower. So right. So and PC means the program counter. Right. So before going to start the basic instructions, you should know what is meant by A? A means accumulator. You can refer to accumulator with its name A or its address 0E0. B with its name or with its address that is 0F0. So the default register bank is bank 0. 00 is the address of R0 or you can refer to R0 with its name like R0, R1 with its name like R1 and address is 01. Similarly, R7 is the name of that R7 register and 07 is the address of R7 in bank 0. PSW is an 8-bit register. You can refer to single bit using this notation PSW.0. PSW.0 means the program status word, the least significant bit. PSW.1 means the next significant bit. PSW.7 means the most significant bit. So P0 is microcontroller 8051 comes with 4 IO ports. The names of those IO ports are P0, P1, P2, P3. P0, P1, P2 and P3. P0 is bit addressable, P1 is bit addressable, P2 is bit addressable, P3 is also bit addressable. So P0.0 means the least significant of port 0. P0.7 means this is the most significant bit of P0. So P1.0 means port 1 least significant bit. P2.1 port 2 the second bit. Right? P3.0 is P3 least significant bit. We refer to that using this notation. C means the carry flag. B.0 means port B or register B 0th bit means nothing but the least significant bit. B.1 means register B the second bit and DPTR is a 16-bit register. You can address to that by loading 116-bit directly in DPTR or dividing the 16-bit number into two parts. One 8-bit number you can put it in higher order register, another 8-bit number you can put it in lower order register. For example, if you want to load 8000 in DPTR, you can put directly 8000 in DPTR register, or you put 80 in DPH, 00 in DPL, and both are same. right? So PC means the program count. So with this foundation, we go ahead in understanding the instructions. Okay, the first set of and the basic instruction is going to be move instruction, right? So move, MOV, it's a data transfer instruction. Move destination comma source, source, destination comma source. So you can copy the content available in source into destination. The first one is going to be move a comma hash 55. Move a comma hash 50. Hash means the pound symbol 55. 55 means this 55. If I put H here, that means it is a hexadecimal number. If I don't put H here, that means it is a decimal number. This means I am semicolon is for comment, semicolon is for comment, and A is equals to 55. So that is what this means. Move A comma hash 55. A will be loaded with 55. Move MOV R naught comma A, R naught comma A. Whatever is there in A, that will come into a register called as R naught. Source is accumulator, destination is R naught. So move move R1 comma A. So whatever is there in A, that will go into R1. Move R2 comma A. So whatever is there in accumulate register, that will go into R2 register. So here move R3 comma hash 95H. 95H means this 95 is a hexadecimal number and you are loading that in R3 register. R3 is getting loaded with 95H. That is what this means. Okay, move A comma R3. Move A comma R3 means whatever is there in R3 register, that will come into accumulate. You can transfer the content of R3 register. You can transfer the content of R3 register into R3 register into accumulate. So this is how we initialize. This is how we initialize one register. This is how we can transfer the content of one register into another register. So here the source is 95. In this instruction, source is 95. Destination is R3. Okay. Some more move instructions and say move A comma hash RN. Example, move A comma hash 0 or FF 255H. So, but this is not the correct way of writing the instruction. If the first if the first number is if the first digit is not between 0 and 9, so you have to put 10. If that is an alphabet like A, B, C, D, E, F, then you have to put 0 in front of that. Okay, digit. So that is the correct way of writing that instruction. Move initializing A with 255. Move A comma RR. Move A comma RR means you can transfer the content of R naught value into A. Move A comma R1. Move A comma R2. Move A comma R3 like this. And move R naught comma A. So RR means move RR. RR means you can initialize, you can use R1, move R1 comma, okay, A. So transferring A value into R1. The next one is move RR comma hash some number, 8-bit number. Move R6 comma hash 36H. So I'm initializing R6 with 36. So that is what this thing. Move move data pointer into hash NN. Hash NN. you can load one 16-bit number in DPTR using this instruction 1234H. So move DPTR comma hash 1234H means this 1234, which is a hexadecimal number, will go into the data pointer register. So what will be there in DPH? DPH, data pointer higher, you are loading 1, 2. In DPL, you are loading 3, 4. Right, 3, 4H. So that is what the single instruction will do. It will load, it is used to load two registers directly. Okay, another way is you can do like this also. MOV DPH comma hash 1, 2H. Move DPL comma hash 34H. Like this, also you can do, or you can directly load 1234H in data pointer register directly using the instruction move dptr comma hash 1234. So these are the basic instructions which are used to load the registers or to transfer the register content into another register content, right? Move a comma address. So this is another move instruction. So move a comma 0 f0. See, remember, observe here, I didn't put pound symbol here. Move a comma 0 f0. This is a number, but I didn't put hash symbol. So if I don't use that hash symbol, it means this is an address. If I use one hash symbol here, it means that is one number. It's an 8-bit number. If I don't use this hash symbol, it means that 0F0 is an address. 0F0 means it's an address of B register. So what happens if you write an instruction like this is the content of B will go into the content of B will go into will go into accumulator. Whatever is there in B register, that will go into accumulate. So now coming to move 0 0 comma A. Move 0 0 comma A. So this means 0 0 is the address of R naught. So whatever is there in accumulator, that will come into R naught register. That will come into R naught register. Move RR comma move R naught or R1 comma 0 E0 0 E0. So you can transfer the accumulator content into R1 register by writing instruction like this, because 0 E0 means 0 0 I didn't put any pound symbol or hash symbol here, which means that 0E0 is the address. So 0E0 means accumulator address. The content available in accumulator will get transferred into R1. That is what this instruction means. Okay, so move 0E0 comma hash 25H. So what is this means? Here in front of this 25H, pound symbol is there. In front of the 0E0, pound symbol is not there. So which means 0E0 is an address, 25 is a number. So you are loading 25 in accumulator. 0E0 is the address of accumulator. You are loading 25H in accumulator. So that is what it means, right? So another very important thing is move R naught comma R1 So you may ask me, sir, move R1, R0, comma R1. Can I do it? No, this is not a valid instruction. But you can do the same thing in a different way. Move 0 0 comma 0 1. So 0 0 is the address of R0, 0 1 is the address of R1. So move 0 0 comma 0 1 H means you can transfer R1 value into R0. R1 value will get transferred into R0 by writing an instruction like this. So these are the useful instructions that you should know before actually understanding the higher versions of the microcontroller, or before going to understand the timer programming and all those sort of things, right? And these are basic instructions. Now coming to the next one is XCH. XCH A comma R not. XCH A comma R not. So what is the meaning of this instruction is whatever is there in R not, it will go into A. Whatever is there in A, that will come into accumulate. Whatever is there in A, that will come into R naught. Whatever is there in R naught, that will come into A. It is an exchange between R naught and A. It's just like swap between A and R naught bytes. XCH A comma 23H. Whatever is there in accumulator, that will get exchanged with memory location 23. Whatever is there in memory location, that will come into A. It's just a swap between accumulator content and 23rd memory location content. Okay. Now coming to the next one, CLR, clear A. A means accumulator. By writing instruction like this, you can put 0 0 in accumulator. CLR means clear. C means carry flag. So you can reset the carry flag by using an instruction called as CLR space C, clear carry flag. Now coming to the next one, SETB C. SETB C means you can set the carry flag with an instruction SETB-C. You can set this particular single bit. The next one is SETB P naught dot zero. P naught dot zero means port 0 least significant bit. You want to set port 0 least significant bit. So the instruction is set B P naught dot zero. So what happens is port 0, the least significant bit will become 1. You want to clear port 2 fifth bit. CLR port 2 fifth bit. Okay. P2.4 port 2 fourth bit. Clear P2.4. So these are bit manipulation instructions. You can change the status of the particular bit. You can reset that particular bit, or else you can set the given bit using set B and clear B. Okay, and coming to the next set of instructions, they are arithmetic instructions. Okay, arithmetic instructions. INC is an arithmetic instruction. Increment. INC is increment. DEC is for decrement. And ADD is for addition. SUBB is for subtraction. And MUL for multiplication. DIV for division. SWAP swap. Swap A means it is for swap operation. So INC INC. INC means increment. INCA means A is equals to A plus 1. A plus 1. DC R naught. DC R naught. R naught is equals to R naught minus 1. So this is, you want to increment A, you can increment it by writing INCA. You want to increment it, you want to increment R7, INC R7. The address of R7 is INC 07. So what is the meaning of that? Same thing. So R7 content will be incremented by 1. It will be incremented by 1. So that is what it will happen. DC, 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 0, E0. So means 0 E0 means accumulator. Accumulator content will be decremented by 1. DECB, DECB, B value will be decremented by 1. Okay, so that is what